sample space. In mathematics, there are many data representational methods. One is pie chart, bar chart, and we have the Manhattan chart and the pulsation chart, curves, straight lines. Likewise, the sample space also a data representational method. In that, we have two subdivisions. One is with replacement, another one is without replacement. Both are important. I will explain both in detail. First, with replacement mean I will explain that first in detail. Thereafter, we will take a look how to represent that in a particular skeleton of graph. First, I will mark there are three blue balls and two red balls. All are same in size. All are compacted inside a box. So, when you put your hand inside the bag and select a random ball, your eyes were closed, so you are going to select a random ball. All are in equal in size, no? So there is no any you don't have any idea while you are selecting, you don't have any idea whether this is blue or red because all are same in size. You will select a random ball. I will mark all this ball as numbers. First, this is first blue ball, B1, B2 and B3. Thereafter, I will mark this one as red 1 and red 2. There are 5 balls. We don't know whether you selected B1 or B2 or B3 or R2 or R1. You don't have any idea. But to find that, we have a thing called sample space to denote that in a sample space to get the probability of outcomes according to the expectation. First, you will put your hand inside it, you will select B1 ball. Okay, B1 ball. And you marked, okay, in the ball you already marked this one as B1. After selection of that, you will mark in your paper. First, I was selected this B1. Thereafter, with replacement, no, that means again you will put that ball into the bag. You will put the same ball into the bag and shuffle it. Again, you are going to select a random ball. Again, also, you can select B1. Sometimes you might get B1, B2. Sometimes you might get B3, R1 and R2. There is a equal possibility to get each ball because each are same in size. There are 5 balls inside. So when you shuffle it, we don't know whether the ball is in initial position or that was changed. So you might get B1 or B2 or B3 or R1 or R2. So these are the things you should understand. First, we will select a ball, mark its color and name. Thereafter, put it again into the box. Shuffle it and select another ball in your second try. We don't know which ball you are going to select. According to the instance, it might change. That's what we are going to represent in the sample space. Sample space is usually you know what is x-axis and y-axis. In this one also we have a horizontal axis and another vertical axis. In the horizontal axis we will mark the probabilities which belongs to first try. First try means when you enter into the box for first time, you selected a ball. No, you selected a ball. That's what denoted by first try. That is denoted in the horizontal axis. The second try. In the second try also you will get another ball. That one will be denoted in the y axis, the vertical axis. In first try, totally we have 4 balls. Totally we have 5 balls inside the box. So to obtain each ball, the probability is same. Probability is same. Again, I am the person who is going to select a ball. I will select the red 2 ball as first. I will mark the color and name. Thereafter, I will again put that into the bag and shuffle it to select another ball. So I don't know which one I am going to select second. Even first also, that is a random pick. So we cannot determine which one we are going to select. But we can find the relative probability. That's what you should understand. Here the skeleton of this graph should be like this. I will draw and then explain that from the beginning. There are 5 outcomes, so you should draw 5 lines. First, you might get B1, sometimes B2 or B3, even R1 and R2. These are the possibilities. We are marking the possibilities in each axis. It might be B1, B2, B3, R1, R2. We don't know which one we are going to select. Same thing is applicable in the second try also. Again also you replace the ball inside the box. So it might be B1 or B2, B3 or R1 or R2. How many balls we have in second try? We have same 5 balls. So it might be B1 or B2, B3, R1 or R2. This is the skeleton for the sample space. Skeleton for the sample space. In the first try we had 5 balls, so I denoted all the balls in the axis. In second try also with replacement, so we will have totally 5 balls. I marked all of them in the vertical axis as well. Now the cross, making of cross, that's important. That means each of these we will have some coincided region, the common region which belongs to the axis in horizontal and axis in vertical. All these events, okay, here we have some interaction like this. All these are called as events. There is a possibility to obtain an event like this. That means you might select B1 as your first choice. In second one also, you might get B1 as a product. It might be possible. First time you might select B1. Again also, since these are random picks, you can or cannot also you can select B1. So there is a possibility to have an event like this. Look at the next one. First time B1, second time B2. You might obtain like that. First time B1, second time B2. These are the events we can expect while drawing these balls. These are the only events. Out of these box, we cannot obtain any events. I'll mark by using cross. All these are called as events. The possible events while drawing this ball thing. Totally, we can obtain 25 different events. Each cross denote different events. When I check with this event, look at this. First, in the first try I selected B2. Second try also I selected B2. That is this cross indicating. When I select this, in first try I selected R1. In second try I selected B1. Look at this event. In first try I selected R2. In second try also I selected same R2. When you think about this event, in first try I selected B3. Second try also I selected R2. Likewise, all these are called as events from this drawing. First draw, it might give you a ball. In second draw also, we will get another ball. Likewise, 5 times 5. Total, we will obtain 25 such like events. Okay, after this, it's easy to understand. We will have some questions. This is related to probability. First, I will give you the question as select the events in both times blue balls. In both times blue balls. This is the probability you should find. We will try to find that. Select the events in both time blue balls. That's what you should find. There are 25 events. No, you should check all events. In first event, I am selecting first one as blue, second one also as blue. Don't consider about their numbers. Here we need both times blues, blue balls. That's the probability you should find. When you think about this event, first time blue, second time also blue. So we need this probability. Next, let's think about next probability. First time blue, second time also blue. First time blue, second time also we will get another blue. When you think about this probability, first time I am getting blue, second time I am getting red. We don't want that probability. We only need the probabilities that is giving you blue balls in both occurrence. So when you select here also first time blue, second time red, we don't want that. Here there's a possibility to have this event. This one also possible. This is also possible. When you think about here first blue, second red, we don't want that. Same thing is here as well. And these three, in all these three instances also we will get both blue balls. Yeah, blue red, blue red. We don't want those probabilities. When you think about here, first time red, next blue. We don't want that. Red, blue, red, blue, red, 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 red. We don't want any of these probabilities. Here also, red, blue, red, blue, red, blue, blue, red, 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 red. We don't want these events also. So finally we found what are the events we required here. Totally there are 25. You should write the probability for the given requirement. Select the events in both times blue ball. There are totally 25 events. In 25, we don't want all events for the requirement. We just need only 9 events to satisfy the requirement. So the probability to obtain blue balls in both occurrence, it would be 9 over 25. This is what you should find. In each time, you should check all the probabilities that is satisfying our condition or not. Thereafter only we can come to a conclusion.